Hello, Algebra 1. Welcome to Lesson 4.3 on solving systems by what's called elimination. Right? So elimination is a big fancy word for getting rid of x or getting rid of y. Right? We're going to eliminate it. So in substitution, we got rid of an x or y by doing substitution. Well, in elimination, we're going to do something called linear combinations, right? Where you add two equations together. Okay? So let's go for it. All right, so here we go. It says, what is the solution to the system of equations? So first off, I want you to see how these two equations are both stacked. These are two standard form equations. But notice how the x's are stacked, the y's are stacked, and the numbers are stacked on the other side of the equal sign. Now, x and y in the top don't have a coefficient, so they're both 1s. The y in the bottom doesn't have a coefficient, but it's going to be a -1. So if we look here, observation, right? Look at your x's. Your x coefficients are different, so your x's are different. But look at your y's. Your y's are opposite of each other. A -1 and a +1, when you add them, they're going to cancel, and you'll get 0y. And that cancellation is what we mean by elimination. We want to cancel one of the variables through adding the two equations. So I'm going to put a big plus sign right here and put a line. I'm just going to add these equations as they look. 1x plus 2x is 3x's. A +1y and a -1y will cancel. And that's going to equal 7 plus 2 is 9. And now notice I have a simple equation with only x. I'm going to divide both sides by 3 because that number in front of x means multiplication. And x is 3. I have my x value. So that is the first step, right? So then the second step here is we need to find y. So I'm going to choose. So you can choose either equation to sub 3 for x. It doesn't matter which one. Now, if I look at the top equation, I feel like that's a little simpler, right? There's not as many numbers. There's plus sign instead of a minus sign, so I choose that one. So I'm going to replace this x with my 3. Now, you could put the 1 in front of it, but you don't need to. So this is just 3 plus y equals 7, right? 3x plus y equals 7. And to solve this for y, I have to get rid of this +3. It is a +3. So we're going to subtract 3 on both sides, and y is 4. 7 minus 3 is 4. So our solution is an ordered pair, x, comma, y. This is our answer, x, comma, y. Don't lose the story from section or from lesson 4.1. It's all about where these two linear equations cross on a graph. Okay, so let's step it up and do another one like this. All right, so again, we're going to solve this system using elimination. Now notice here, right, if I look at the beginning, this x has a 1 in front of it, so my x's are different. And if I look at my y's are also different, right? So the question is, okay, now we have to multiply one of our equations by something. Now, if you know anything about multiplication, if you multiply the number 1 by anything, it becomes that thing. So 1 times 7 is 7. 1 times -12 is -12, right? So if you see this x right here, this 1, we need to multiply this 1 by something. And we need to multiply it so it becomes opposite of this 2 down here, right? So if we multiply the 1 by -2, it's going to be a -2x, which is opposite of 2x in the bottom, and they're going to cancel. So in this case, what we're going to do is we're going to take a big parenthesis and put a times -2. You can put it behind it or in front of it, I don't care. I'm going to put it behind it. And you're going to distribute that -2 to all 3 terms. So that equation now becomes -2x. 3 times -2 is -6y. and 7 times negative 2 is negative 14. The second equation, we're not going to multiply by anything. 2x plus 2y equals 6. And now notice, your x's are opposite, right? Negative 2x and 2x. So now we're going to add the two equations together. The negative 2x and the positive 2x cancel. Negative 6y plus 2 is negative 4y. And negative 14 plus 6 is negative 8. And now our equation is in terms of y, so we just divide both sides by negative 4 to get the y by itself. And negative 8 divided by negative 4 is 2. And we have our y value. So now again, now we're going to choose either original equation. All right? And we're going to substitute 2 in for y. Again, I'm going to pick the top equation because I know that this has just an x, right? There's not a 2x. So it's going to say x, because I don't know what x is, plus 3, but now I know what y is. Y is this 2 down here. Equals 7. I'm going to simplify 3 times 2, that's 6. And then to get x by itself, I'll subtract 6. And x equals 1. So here, right, your solution is x comma y, 1 comma 2. All right, let's do one more word problem here. Okay, we're using this elimination technique. All right, so it says a florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? So a regular bouquet has 5 roses and 11 peonies. Each mini bouquet has 3 roses and 5 peonies. Okay. Now, in this problem, there's a couple ways to think about this. Number one, right, they give you the total number of roses and the total number of peonies. So I believe that's going to be our two equations. It's not going to be, we're not going to break it up by regular bouquets and mini bouquets. We're going to break it up by roses and peonies. So what this means is, if I want to know how many of each type of bouquet I can make, those are my variables. So let's let x be the number of regular bouquets. And let's let y be the number of mini bouquets. So let's start with the roses. Okay? So there are 5 roses in a regular, and there are 3 roses in a mini. So 5 in a regular plus 3 in a mini, and we have 118 roses to do. Okay, what about the peonies? There's 11 peonies in a regular and 5 peonies in a mini, and we have 226. So for the peonies equation, 11 in a regular plus 5 in a mini equals 226. And now we're going to solve this using elimination. Now here's the issue here, right? Notice that the x's are different numbers and the y's are different numbers. Also notice that they each have a coefficient other than 1. So here is where we have to actually take both equations and multiply them both by something. Now, the easy thing to do, right, is just choose one of the variables, x or y, and multiply each number by the other number, right? So in this case, because x has an 11 here, I'm not going to choose the x's. I'm going to choose the y's. So we're going to take the 3 and multiply it by 5. We're going to take the 5 and multiply it by 3. Now, there's an issue, though. They're both positive. So we need to make one of these a negative. I'm going to make the smaller one a negative. I'm going to make the 3 a negative. It doesn't really matter, right? So now we're going to distribute to both equations to get 2 brand new equations. So watch. The 5 goes here, here, and here. That becomes 25x plus 15y. And then 118 times 5, use a calculator, that's 590. We'll do the same thing to the bottom. Negative 3 to all 3 terms. That's going to be negative 33x minus 15y. And again, use a calculator. That's negative 678. And now notice your y's. plus 15 minus 15. That was the point. We are now going to add our equations to get the y's gone. So 25 and negative 38 is, or negative 33 is negative 8x. The y's are gone. 590 and negative 678 is negative 88. And now because the y's are gone, we can solve this for x. We're going to divide both sides by negative 8. And I get an x value of 11. So how many of each type? So right now I can do 11 regular. So I'm going to put that 11 regular bouquets. But now about how many minis, right? Well, now here's the second step. We're going to take our value of x and plug it into one of the original equations. I'm going to pick the first one because it has smaller numbers. So now we'll do 5 times 11, so replace the x with 11, plus 3y equals 118 into the original equation. This is 55 plus 3y equals 118. And now it requires two steps. Get the 3y by itself by getting rid of this 55. It's a positive 55, so subtract it. So we get 3y equals, use the calculator, that's 63. And then this 3 is multiplying with the y, so let's divide both sides by 3. And y is 21. And that means we can do 21 mini bouquets. And that's how many of each bouquet we can do. All right, very good. So this is the first video. The second video for lesson 4.3 is coming up next.